Like every year, around 1.5 lakh people die in India due to the road accident. What motivated me was not just the technical challenge, but also the vision of seeing this research eventually deployed on real-time vehicles, like where the public will use what technologies we are developing. After the PMRF fellowship, lots of students have shown interest because this is a very attractive fellowship. Like students gets the stipend equivalent to someone who is getting at jobs. It's not because like they lack talents. It's because they don't know where to find the right opportunities. So exactly, I think here TAYOG is creating a real impact.
This is the first episode of TAYOG Talks. Today we have with us Mr. Abhishek Thakur, who recently completed his PhD in electrical engineering from IIT Hyderabad as Prime Minister's Research Fellow. During his PhD, he has worked extensively at IHAL, which is India's first autonomous vehicle tester, where he contributed to the development of the country's first autonomous campus shuttle. We're very excited today to hear about his journey from the man himself. So thank you, Abhishek Bhaiya, for joining us, and welcome to the meeting. The first
So
thing I'd
thank
like
you
to
so
ask.
much
Yeah,
for having me here.
okay.
So basically, like I want to say that this TAYOG initiative taken by you guys are really wonderful. And like some students who are pursuing research uh, are not able to get the opportunities, are not able to get the information about the opportunities. It's not because like they lack talents. It's because they don't know where to find the right opportunities. So exactly, I think here Tayog is creating a real impact. And like I wish something like Tayog existed during my research journey when I was a student. So okay, we can have the conversation now. Thank you so much for having me today.
Thank you so much for this kind word. That is like developing at a very good pace, and we're very happy to have you. So the first thing I'd like to ask that you told me that you did PhD directly after your B.Tech. So how did that happen? How did you do that?
So there are multiple ways to get into the PhD at IITs. So like the most two common ways are getting after MTech and another is after B.Tech. So after MTech degree, if you have done from IITs or some national importance institute, then you don't require the GATE score. But if you want to do PhD in IIT just after your B.Tech, in that case you need the GATE score, and that is and also a good CGPA. And the shortlisting criteria is based on the GATE score and the CGPA. And once you get shortlisted, then you will having the exams conducted by each IIT separately, and after that there will be interview round with the multiple professors. And also, like I would say that before applying to PhDs at IIT, you can also go through the research areas of the professor and explore their research area and show interest in them by mailing them. So if your profile gets shortlisted for interview or exam, then you will have some extra benefits. So here also, I think platforms like Tayog will help to find out the right projects and the right professor of your interest.
So yeah, you also told me that you did a PhD with Prime Minister Research Fellowship. So what exactly is that, and how did you do that?
So the Prime Minister Research Fellowship is the initiative by the Ministry of Education by Government of India. It was initiated in 2018. So after the PMRF fellowship, lots of students have shown interest because this is a very attractive fellowship. Like students gets the stipend equivalent to someone who is getting at jobs as well. So people are attracted toward this fellowship and the research grants provided by the Ministry of Education. And like PMRF also have two schemes. One is the lateral mode and one is the direct mode. So for availing the PMRF fellowship, first student have to take admission into the IIT or any of the central university where PMRF where the students can get the PMRF, because that depends on the NIRF ranking. Only few central universities and all the IITs are eligible for PMRF fellowship. So once you get admitted as a PhD scholar in those institutes, then you can apply. The first mode is a direct entry where you can apply within a year. In that, they will shortlist based on the GATE score, and also they will check your research proposal. So you have to write the research proposal. And the second method is the lateral entry. There also you can apply up to the 2 years of your PhD. So basically in IIT's PhD go for 5 years. So up to second year you can apply there. The shortlist, like the selection criteria depends on these things. The first is your research proposal, and the second is your research profile or background. Like if you have any papers in your B.Tech or masters, good papers, and that will give the extra advantage to the candidates. So I have applied after my first year at IIT Hyderabad, and my professor, like I was the PhD under Professor Raj Lakshmi. So and our research work was really innovative and trending at that time on the autonomous vehicle. So our research proposal was very good, and in that case, I got shortlisted, and also I had a IEEE conference paper in my B.Tech, so that also helped me a lot. So this is the way to get into the Prime Minister Research Fellowship.
So coming back to Tihan, like what exactly was your role? Can you tell us more about your role in Tihan and who were the other workers and how exactly was the work distributed among the people?
So Tihan is a Section 8 company established at IIT Hyderabad under the National Mission on Interdisciplinary Cyber Physical System (NMICPS). That is again funded by the Departments of Science and Technology, Government of India. So in Tihan, the major work done is on the autonomous ground vehicle and the autonomous UAVs, unmanned aerial vehicles, and connected vehicles. So I was working in the project of UGV, that is unmanned ground vehicle, or we say autonomous vehicle. So Tihan provides the state of the art facilities for the research, where it is a first autonomous navigation test bed in India. So it is basically for development and validation of the algorithm before real time testing in the vehicle. So Tihan have all kind of scenarios like traffic lights, lanes, waterfall simulators for autonomous vehicle, and there are multiple environment for drones and other technologies as well. So my work was on autonomous vehicle, and in autonomous vehicle again there are multiple teams. One team works on camera based solution, another team works on radar based solution, and some of the teams, like I was working on the lidar based solution. So I will just explain lidar in one line. So lidar is a sensor which creates a 3D point cloud. Like camera gives the 2D image, so we are not able to find the exact geometry or the depth of an object. With lidar we can get the accurate 3D estimation of any obstacles or any object. So lidar is useful in mapping, localization, and other applications for autonomous navigation. Now coming to the LiDAR team, which is one of the sub team in the autonomous vehicle at Tihan. So when I joined PhD, I was first assigned with a senior PhD scholar who trained me, like what existing work is going on in that area based on LiDAR sensor and camera sensor. Then after that, I carried forward the work under him, and then later on, I was also assigned with many MTech students, interns, and the staffs at Tihan, where I also used to give trainings who were working on the autonomous vehicle, on the autonomous campus shuttle, which was developed by Tihan. So our team member was around 5 to 10 members, like just a lidar team, 5 to 10 members, sometimes 7 or 8 members like that. And the complete autonomous ground vehicle team was having around 30 to 35 members, including camera team and the radar team. And also some people were working on sensor fusion. I was also the part of that. So sensor fusion means working with multiple sensors like LiDAR, camera, other sensors as well. So this was the team structure and the work in the Tihan. So everyone have to work on their individual project, and we used to collaborate with each other, like with different teams, and also we used to learn from each other. The environment was good so that we are able to discuss the ideas with other and then implement it together. And then we used to have weekly reviews with our professor, and after the review, the professor used to say us to show the demo where we used to deploy in the real time autonomous campus shuttle, and then we used to check whether our algorithm is working or not, and then we again rectify it if any problem occurs. So like this way in Tihan the work is going on, and work is also divided among all the members. Like in lidar team also, I was expertise on mapping and localization. One of my team member was working on path planning, like obstacle avoidance and all. And at the end we used to collaborate with each other and integrate all the algorithm together in a common autonomous vehicle. So it was a very good environment to work together with a large team and who were expertise in different domains.
I think that after your B.Tech in electrical engineering, you may have different career prospects. What inspired and motivated you to take up this project that you have to do?
The first time my research interest grew when I had done a summer research internship at IIT Guwahati. So during my after my third year of B.Tech, I have joined as a summer research intern at IIT Guwahati, where I have worked on 5G and massive MIMO technology. So there I have worked under a PhD and professor directly. So that time I really feel that research is a really good work, like where I have to think, I have to do myself and develop something new. So from there, the research interest grew under me, and then after that, I came to IIT Hyderabad. So initially, I was planning to work in the same wireless communication domain, like in the 5G or 6G. So my professor was also expertise of that. But that time, Professor Raj Lakshmi got a project from the government, that is Tihan. So there, and I saw that this Tihan project, we have to work on autonomous vehicle and autonomous drone. And then I felt like in India there is a problem of road safety. Like every year, around 1.5 lakh people die in India due to the road accident. So this is a huge number. So here, if like safe navigation can be done using the autonomous vehicle, that can help. And also like connected vehicles, where two vehicles are connected to each other using internet of things and communication technologies. So on this also another team member is working. In this way, safety can be provided, and not a complete autonomous vehicle. Let's suppose the ADAS solution, like in some vehicle, if we implement some autonomous emergency braking, AEB, so that can also reduce accidents. So these were also the part of our work, like autonomous emergency braking, autonomous parking. So these ADAS features also we have worked on. So if that is implemented, like most of the private companies were working with Tihan, so they are implementing the algorithms, and then that also improve the safety and make the transportation safer and more efficient. So I this kind of work was really challenging, and I got interest in it because it was a very new kind of work in terms of in the scenario of Indian condition. And what motivated me was not just the technical challenge, but also the vision of seeing this research eventually deployed on real time vehicles, like where the public will use what technologies we are developing. So that sense of social impact really kept me inspired throughout the project.
So for our listeners who have no idea about autonomous navigation, which is a very unfamiliar topic, I think many of us. Can you just explain the core science behind it, like simple terms, like which kind of sciences, for example, machine learning or anything. Like, what exactly is using? What is basically the core science behind it?
So before going into the core science behind the autonomous navigation, I would like to explain that there are five different levels of autonomous vehicles. So starting with level 0, where there is no automation, and level 1 means some driver assistance features will be there, like cruise control or lane positioning system. Then level 2 is like occasional self-driving. Level 3 and level 4 is like limited use of the drivers. In level 5, it is a full self-driving under all the conditions. And autonomous navigation in simple terms is can be correlated with how we drive. Like when we drive, we do three things. First, we see the environment, then we think what action we have to take, and then we act. So the core principles behind this autonomous navigation is the sensing. So where different sensors are used, like camera, lidar, radar, GPS, so that sees the environment. And after looking at the environment, various algorithms are developed, like object detection, object tracking. Here we use the machine learning and deep learning based approach. And also one more thing, that the solution which is existing in US or China, that cannot be directly implemented in India, just because the types of obstacles in India, or the types of traffic or the crowd in India, is different as compared to the other countries. Like obstacles like auto rickshaws, bicyclists, bike, these are more found in the Indian roads. And also sometimes animals may also come. So we have to train the deep learning model based on the Indian data set. So Tihan also have a data set collection vehicle, where they have collected data of around 5,000 kilometers in different parts of India, including in Hyderabad and then in other parts, and also in the state like Jammu and Kashmir, to get the fog data, because vehicle have to navigate in foggy condition if they are driving in the winter in the North India part. So the first thing is to sense the environment, to see the environment, just like how our eyes look at the environment when we drive the vehicle. The second is think. So once we have the perception of the environment, then we try to process all this information and try to predict how uh, other objects or other obstacles are behaving in that environment. And then we have to plan our own trajectory, in which direction we have to move, and we have to plan the trajectory to move from the current position to the goal position. Like the immediate goal means the next 10 meters or next 20 meters, how we drive. And then after that, act. So act is the actuator parts. And once the algorithm provides the command like acceleration, brake, or steering, rotation. Then the actuators uh, implement it on the vehicle, and vehicle uh, execute those commands to follow the trajectory to move to the to move to the goal position. So at its core, autonomous navigation is all about combining sensing, perception, and decision making, and the control. So this is the core science behind the autonomous navigation in the simple terms.
Okay. That was very insightful. That was extremely insightful. I think many of us gained a lot of knowledge from that. And now we actually know what autonomous navigation is and how it's implemented. And also, an article in the Logical Indian states that the Tihan process achieved technology readiness level 9. Could you please explain what that means?
Technology readiness levels are a way to measure like how mature the technology is, like the technology we have developed, how matured it is. So it starts from the level one. So the level one is just like the basic principles absorbed, and that something is reported like that can be done. The technology can be like just kind of proposal kind of things, and the starting of the implementation with basic principles. Now coming to the level two, where like technology concepts or the application is formulated. So like that, there are 9 levels of technology readiness levels. The ninth level is the actual system that is proven through successful operations, like that is ready to deploy in the real world. So our autonomous campus shuttle, we started from TRL1, from the basic principles, and we have tested multiple times in Tihan test bed and inside the campus. And the once we had the like up to level 4 or 5, where it was like level 4 is the uh, system that is validated in the laboratory environment, like in the Tihan test bed. So that time we have shown to our director sir also. Then he gave approval that we can deploy this in campus for the public use. So we deployed it. Then once the vehicle was running, every day we were facing some problem, like some feedback from the users, like the public who is sitting on that vehicle. So they were giving some feedback to us. Then accordingly, we were modifying our algorithm. And at the level 9, like the technology became very matured, and it is deployed for the uh, like the public users in the IIT Hyderabad campus. As you can see, the vehicle runs from hostel circle to main gate. That is a 3 kilometer route, around 6 to 7 times daily in the morning and afternoon time. So that became very mature technology. So this is the level 9 of TRL. So it means like the system was tested successfully outside the lab and deployed on the real time environment, or the like as it is our vehicle is deployed in IIT Hyderabad campus. So it's shown to operate like safely with real passengers. So this is the basically the definition and the meaning of TRL 9.
Okay. So basically, the hard bus in IIT Hyderabad has reached a maximum level that needs to be achieved. Okay. So very good to know.
And still
Now,
like some improvements are required in that. So those for that also, if we get feedback from the users, accordingly we modify. So there will be something we have to add upon that. So like nowadays one of the team members have worked on obstacle avoidance. So when it sees some obstacle, it avoid, and it plan the path and avoid it, and then it follow the trajectory. So every day the technology is getting matured, but we have come up to the highest level of maturity where it can run without the support of driver.
when we talk about autonomous navigation, the first thing that pops up is safety. People can't exactly trust how safe can something that's autonomous can be. So, what measures did you implement to ensure that it is completely safe?
Yeah, safety was the top priority from day one, like as guided by Professor Rajlakshmi. Because let's suppose if I say someone that our vehicle is 90% safe, so nobody will sit in that, because that 10% unsafe can lead to the injury. So that why safety should be 100% in this kind of technology, but it cannot be achieved 100%. So at least 99.999%. So this was our one of the top priority from day one. So like how we improved our safe navigation. So like the first thing what we have done, like we have tested multiple times in different kinds of environment, and we have used dummy mannequin and then dummy cars, which is made up of foam and all, to test the crash test with the dummy. And also we have taken data set across the country. So we have try to run our algorithm on the data set which is taken across the country in different states, in different scenarios like night, day, rainy, and the foggy condition. So after testing into the different scenarios, the vehicle safety has improved, and but we cannot achieve, as I told, 100% safety. So for that, we have also given a safety features of emergency stop in the vehicle. So let's suppose if somebody is feeling difficult or different, then they can press that button. It is under all the seats, and they can press that red button, and the vehicle will stop at that time itself. And we have also tested our algorithm extensively in first in the simulation environment, and then we try to deploy on the vehicle. And once the code is validated, then it go into the deployment phase. So and we have also designed the redundancy into the sensing and control. And also we have developed the sensor fusion mechanism. So here sensor fusion, what it does, let's suppose one sensor module fail, then the other sensors come into the picture. Sometimes sensor may fail, like if camera is unable to detect one of the objects. So that time we have LiDAR and radar, which detects the obstacles and gives the input. So once we have multiple sensors, like the sensor fusion technique, so safety can be enhanced. And so we have carried also the step by step trials, and then starting in the controlled environments like in the Tihan test bed before moving to the outside environment like at the campus or even outside our campus. So in that way, we have tested multiple times and to make sure that the system was trustworthy at every stage. And also we have deployed this vehicle in different government organizations at like in the Navy campus and in other government organization as well. So these were the steps we have taken to improve the safety.
Okay. Now that's really assuring to know that so much goes into making a vehicle safe for this use. Now, how did working at Pihan compare to your traditional lab-based research environments, like people who are doing normal PhD? You work directly more like in the industrial sector. So, how did that compare to your traditional lab research opportunities?
Yes, so both the way are really important, like working with the products or hardware, and the second is lab-based research. The difference is like a traditional lab often focuses on the theory, mathematics, simulation, and they do all the experiments in the simulation platform. But the real algorithm comes from there only. So in Tihan also, first we start with what traditionally research is done in all the labs, the similar kind. And after once we get the algorithm tested in the simulation environment, we try to deploy on the real-time vehicle or we test with the hardware. So at Tihan, like it was about taking research all the way to the real deployment. So this is one extra advantage of working at Tihan as compared to the traditional lab-based research environments. And also in Tihan, like the people from different backgrounds are there, like students from the electrical engineering, mechanical engineering, computer science engineering, AI engineering. So from all the departments, students are there. So we learn from each other and collaborate from the students with different backgrounds. So it also helps us like interdisciplinary. It gives us the interdisciplinary knowledge. Like I was not that good in the mechanical stuffs of the vehicle, but one of the team was working. I was also with them, so I have learned something about the drive-by-wire technologies and how they are making the vehicle run using the drive-by-wire technology. So this is one of the advantage. And also like Tihan is like a startup ecosystem where uh, they have to generate revenue as well after developing the product. So for that, it is a very challenging environment, and the workload will be definitely a little higher as compared to the other labs because we have to develop the product which can generate revenue for the Tihan. And also, Tihan have their own staff who are working in that. Basically, the students from MTech and PhD they are focusing on research-oriented work, and from research from lab to market, like to take the product from lab to market, the staff at the Tihan organization, they are also working very hard. So for me, like this made the research very exciteful and very impactful.
Okay, that's very good to know. Now, this whole autonomous navigation thing at Bihar is a very extensive process where success was not exactly guaranteed to you. So, was there ever a moment where you doubted yourself, maybe doubted in the whole thing, but you still completed it? So, what kept you going?
Yes. So before coming to the Tihan research, I will come to the PhD part as well. So when I joined PhD in initial months, like the student struggles a lot because they have to figure it out what research they have to carry, and how they will carry forward with the research work. Because students directly come from MTech or B.Tech. For MTech student, it will be little easier because they have done some research work previously. For B.Tech students, it becomes little challenging and struggling. So in those days, we used to start doubting whether we will be able to complete the research or develop something new or innovative. So in that case, I also felt like in the initial first or second month, I felt like leaving from the IIT Hyderabad. But then I consulted my guide openly. I did not kept inside me. I directly told that I'm not feeling good here. And then she guided me through the whole process and the journey of PhD and how attractive it can be. What are the opportunities after PhD? So after that, I got I convinced myself, okay, let's give a time. And then after working for 2 3 months 4 months, like after the first year of my PhD, basically in the first year mostly we will be having the coursework where we will do course of the MTech, because the direct PhD student have to do the MTech coursework. And also the students who joined after MTech, they also have to do some basic coursework around 12 credit at IIT Hyderabad. And the students from directly from the B.Tech have to do 24 credit. So in the second year, after 3 4 months, once I crossed the threshold barrier of research, then I start loving my research work. And after that, things went very smoothly. Like only thing is required is the first breakthrough. So first breakthrough, maybe either you get a first wonderful output which can generate a research paper or patent for a researcher. So after that, the things go very smoothly, and we start loving the research work until we finish it. So this was the moment of doubt in the beginning, and one more struggle comes before the final year, like where a student have to figure it out what they have to do after PhD. So here I will say that students need to uh, start looking at the work which is done in the different universities. So there they can carry forward their work from one like from the current institute to the next institute. So in this way, a student can keep their PhD journey very smooth. And I will say like even like a first breakthrough is required. After that, the researcher gets the interest in their work.
Okay, that was really motivating. Uh, Finally, what advice would you give to someone that is just starting out in research? Maybe someone is confused about how important mentorship or networking are in a PhD journey. So, if you could say something to them, what would you say?
So my advice would be don't get scared in the beginning. Like PhD is a very long, like it's just like a kind of marathon race. So in the beginning, be slow but be consistent, and don't get afraid of starting small things and failing often. So once we fail multiple times, then we get to know like what can be done. So after getting the failed result only, we get the actual things. And research is like less about having all the answers, and it is more about being persistent in finding them, like what new can be done. So here the two important thing is like curiosity and the patience. In PhD, patience matter a lot. It matters more than the speed, because sometimes we do a work for 1 or 2 years and 2.5 and 3 years also, then we get a work which is equivalent so that we can submit a journal. So here we have to be patient and be consistent, so that the work can be accumulated and then published what is the requirement for the PhD, that is the journal or the patents. So and we should not get afraid, like, and we should not look at others research, because if you look at some other people research, some people publish more journals, some publish less journals, but at the end it matters the quality of the journals. Like I have seen many of my seniors who had only 1 or 2 journals and they get into as a professor at IITs, but someone is having 10 or 12 journals is still not able to find the professor in the good colleges like IITs. Obviously they get at other place, but everyone is having dream to get into IITs, because getting into IITs is important, because there you don't have to teach, you have to do research as well. But in general college, the professor is more oriented towards the teaching. So this is one difference, like getting professor at IITs and other institute. So we should focus on the quality instead of quantity. And also we should be very patient and wait for the uh, like results. If we are doing good work, we will definitely get the good results. And one more advice, like in the final year, uh, like you try to bind up most of the work by fourth year of your PhD. Final year should be only for thesis writing, and for submitting the journals, or improving it. Like sometimes when we submit the journals, it gets rejected. Then again, we have to give the response to the reviewer, and then again we have to modify it to make it acceptable. So in the final year, keep things for these, and also most important, keep the time for exploring the opportunities. Like after PhD, there are opportunities are in all the sectors. Like we can join industry, we can join postdoc in the foreign institute, the research position at the foreign institute. Here the platform like TAYOG can help, because at my time I used to search on the career page of each universities. Like if I am searching postdoc or research associate role in the European university, then I have to search each university's career page. But in Tayo, all the things are combined together, all the research jobs are listed together. So here we can use this platform to find the opportunities for ourselves. And this will be a very helpful platform. I wish this were existing at my time. And apart from industry postdoc, and directly we can join as a professor. Like uh, in some of the institute like NITs and triple ITs, there are different PhD scholars who are directly getting after PhD as well. So there are different opportunities in all the domain. So final year should be kept for that, just writing the thesis, publishing the journals, and finding the opportunities. So try to bind up work by fourth year, because at the end we have to move forward in our career. We don't have to be there only in the PhD in the same institute. So for that, final year is very crucial. And so students should be like working in such a way that the most of the work is completed by the fourth year. So this is one of the advice I will give, so that they can have the better future.
Okay, that was very helpful and very insightful. So thank you for those kind words for Theo, and that's exactly what Theo tends to achieve. But it wants to serve the platform for all the researchers, all the students, for everyone to connect together in one place that helps them get all the research opportunities and internship opportunities in one place. So currently, Theo is partnering with colleges and universities to offer interdisciplinary faculty uh, for top class research and like research focused to the opportunities in one place. We are going at a very good. So yeah, that's all for today. Thank you so much, Abhishek, yeah, for joining us. And it was learned a lot of things today. And I hope your words will help out a lot of students and a lot of researchers that are just starting out. And yeah, that was very insightful. Thank you very much.
So thank you so much, Himanshu, for having this discussion, and it will really help a lots of students who wants to carry forward their career in the research field. And also, like when we were in B.Tech, that time we were not having that much idea of research, but you guys being in B.Tech, creating a platform which will help all the researchers to connect the other researchers on the single platform. So it is really an innovative platform. And thank you so much for this wonderful discussion.